Hey everybody, it's Monty and Miller, and this week, Skill Builder Week. Dun dun dun. Been a while since we had a Skill Builder Week. There's really nothing about this week that has meaning in the real world, but we gotta have these skills in order to make sense of the real world. Okay? So, welcome to week 26, and we are in late March. Everybody ready for spring break? It's coming up. All right. So we're working with this thing called the radical. We've used a little bit of the radical and the squared button on the calculator, but that's not enough. Now that we've discovered pi, and it's this never-ending number. Seriously, it goes on forever and ever and ever. In order for engineers to build things, we have to be exact. Well, to be exact, you can't use round numbers. We've got to have the whole number. So, pi. It's a button, and we don't want to abbreviate to 3.14, otherwise the circle's not going to be quite right. The area of the circle is not going to be quite right. Okay, so, enough of that. We're on with Skill Builder Week. The first thing is, Mr. Miller is going to hand you a sheet of paper. And this is what we call the foldable. You guys remember foldables? We've been out of school for so long, we haven't folded anything. All right, so we have a sheet of paper, front to back, and it's a foldable. Okay, so we fold it down the middle, and we're going to have page 1, simplifying radicals. Then we're going to go to multiplying radicals, and then we're going to go to dividing radicals. Okay, and then we'll see how much time we have left in the week for this thing called rationalize the denominator. And for those of you that did Mathia, it does it for you. When you type a square root in the basement, poof, the answer changes and you're like, what happened? That's called rationalize the denominator, because in math, there are certain things we just don't like. Square root 5 in the basement. That's called the denominator. We hate it. Okay? There's reasons for it. All right. So everybody grab a sheet of paper, do your foldable, get it all together, and you're going to take notes on it, and I would keep it for the rest of your math career. Serious. This is one of the greatest tools in all of math for the next 2 years. Serious. All right. Here we go. Okay. So last week we talked about pi. Okay? Circumference divided by diameter. And then we filled the circle with these things called special right triangles. Now, this whole week we're going to focus on radical 3, radical 2, radical 2, radical 3. What are these things called? Square roots. Okay? So, square root, radicals, okay? How do we work with them, okay? And why do we work with them? Here we go. All right, radicals and square roots, I can simplify, I can multiply, I can divide. Well, the first thing we should do is refresh our memory about perfect squares. Perfect squares. Numbers that, when we multiply them together, they stay whole numbers. And when we take the square root of them, they stay whole numbers. Now, I've been showing you on all these calculators that squared and square root, okay, they're the opposites of each other. Okay? How about this calculator? Squared, square root. They're next to each other. They're the opposites. They're the inverse. Okay? So, we got this little tool here. 1. What's 1 times 1? 1. 2 times 2. 4. Now you chant. Oop. Clicked the wrong thing. Ah, Monty. All right, let's start over. You're supposed to chant. What's 1 times 1? What's 2 times 2? 3 times 3. 4 times 4. 5 times 5. Can you see perfect squares? Okay, let's do the rest of them. 6 times 6. What times what is 49? 64. 81. 100. 121 is 11 times 11. Hey, everybody knows 12 times 12 is 144. Now, these we don't see as often, but we love to put them on tests, okay? So, 12, 13, 14, 15. Okay, now take a minute. On the back of your foldable, this is the very back side of the foldable, I would take a moment and write some notes, okay? Go ahead, pause the video, and write these down. We want to be able to go back and forth. We want to have them in the top of our heads because this is the basis for simplifying radicals. Okay? All right, welcome back. Now, before we go any further, you should have just a little bit of space back here. And I want to build a factor tree. So in the classroom, Mr. Miller probably will ask, hey, let's build a factor tree. Okay? And in my world, we just got to pick a number and factor it. Okay? So, let's see, if I take, I don't know, the number that's coming to mind is 54. Okay? So, for this video, I'm just going to write the number 54 down. Okay? So first of all, everybody write down factor tree. Okay? And in the classroom, you guys can pick a number as a group and then you could work on it. In this one, we're going to use the number 54 and we're going to build a factor tree. And some of you might remember factor trees from middle school, some of you may not. And that's okay. All right, factor tree. What a factor tree is see, 32. I'm going to use a 32 over here as an example. What are all the prime factors of 32? Well, I don't know, but I know it's an even number. And I know that 32 is made up of 2 times 16. Well, 2 is a prime factor, so we keep the 2. And I know that 16 is built up of 2 times 8. And I know that 2 is a prime factor, I know 2 is a prime factor, and I know that 8 is 2 times 4. And I know that 2 is a prime factor, I know that 2 is a prime factor, I know that 2 is a prime factor, and I know that 4 is 2 times 2. Okay? All right, so 32 is the same as 2 times 2 times 2 times 2 times 2, 5 of them, right? 2, 4, 8, 16, 32. Cool, okay? We want to be able to build factor trees, okay? So we're given a number. Can we build a factor tree? And when we build the factor tree, then we can analyze it from the standpoint of perfect squares and simplify it, but not lose the integrity and have a non-round. We don't want to use round numbers. Okay? So, factor tree. What are the factors of 54? Okay? Now, it's okay. Use a calculator. There's nothing wrong with that. And we'll just grab this calculator here. And I'm just going to type in a 54, and I know it's an even number, so 54 divided by 2. There's nothing wrong with grabbing a calculator to help you. 2 times 27. Well, I know a 2 is a prime factor. Now, what multiplies to 27? Okay, it's not an even number. You guys know the rule of multiples of 3? 2 plus 7. 2 plus 7 is 9. That's a multiple of 3. So 3 times something. 3 times something. 3 times something, right? All right, thank you. 3 times 9. So now we got a 2, we got a 3, and what are the prime factors of 9? Yes, 3 and 3. Okay, so a factor tree. 2 times 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27, times 2 is 54. Okay? Once we build these factor trees, we can analyze and simplify. That's our goal. Alright, so pause the video, write some notes on the back of your sheet here about factor trees. Alright, here we go. Welcome back. Okay, very first thing on your cheat sheet. Okay, when working with radicals, you want to simplify the expression as much as possible without using decimals. Okay, we don't want decimals. Pi goes on forever. The square root of 3 goes on forever. Okay, we don't want to round. No rounding. Okay. Alright, so there's no rounding. Here we go. Coefficient. The number on the outside of the radical is called the coefficient. Okay? So, put a number in there. And I'm just going to say -3 for this video. Okay? Now, what we're trying to take the square root of is called the radicand. And in this case, let's just put something that's not perfect. 7. And then, as you've heard Mr. Miller and I talk, that's called the square root symbol, but we like to call it the radical sign. Okay? Alright, here we go. Remember, at any time, just pause the video. Okay, we want to simplify. Well, how do we simplify a radical? Okay, we're looking for items that are perfect squares. Okay, we're looking for items that are perfect squares. Okay, and we got this little cheat sheet here, and you have your cheat sheet on the back of your foldable. All right, so 32. Now, if you were taking notes, we just did 32, but let's do it again. Okay, and it's an even number, so I know that 32 is 2 times 16, 2 times 2 times 8, 2 times 2 times 2 times 4. I'm going to stop right there. Now, before we go any further, I want everybody to agree 3 times 4 is 12. What's 4 times 3? 12, right? We got all these rules in math. Now, the square root of 32 is equal to something. The square root of 2 times 16 is equal to the same something. The square root of 2 times 2 times 8 is equal to the same something. The square root of 2 times 2 times 2 times 4 is equal to the same something. Okay? Now, the next thing is legal. I can bust this apart. 2 times 2 times 2 times the square root of 4. If you put that into a calculator, you're going to get the same number. Now, what's the square root of 4? Come on, what's the square root of 4? Second square root 4 is 2. The square root of 4 is 2. Square root of 4 is 2. Oop. Square root of 4 is 2. Square root of 4 is 2. You mean to do... Oop. You mean to tell me that right here, the square root of 4 can be rewritten with a 2. So now I can say 2 times the square root of 2 times 2 times 2 is the same. Oh, wait a minute now. I see another 4 in there. 2 square root 4 square root 2 is the same. And we just know that the square root of 4 is 2. So now I get another 2 out here. So now I have 2 times 2 times the square root of 2. It's the same. All right. End result, 4 square root 2 is the simplified version of the square root of 32. Now, it's going to take a couple days. Most of you are already seeing the pattern, but I want everybody right now to test it. Okay? I want you to go to a calculator and I want you to type in square root 32, and then I want you to type in 4 square root 2 and get the same number. Serious. Okay? I want you to see that these are indeed the exact same. Okay? Now, the reason we're doing this is we don't want to have, in math, engineers, the building's not going to stand up if they measure and use the number 5.65 and we're going to round. We're going to estimate. We're going to round it. The building is not going to stand up. Okay? No. We need to be exact, but this is not as powerful a tool as this. Okay? So, in class, have a little discussion, talk about the power of being exact and the power of having the 4 on the outside. And this process, the more you do, the faster you get at it. And we haven't been working together. We haven't had a skill builder week for a while. So this will take a little bit of time, all right? Okay, so let's just start rolling. I'm assuming you've already had your discussion in class. Here we go. Okay? All right. Problem number 2. Okay? The -7 we're happy with. Okay? But we need to discuss how to simplify the square root of 20. Is there something we can pull out? What are the factors of 20? Okay? And again, you can build a factor tree, but I'll bet you somebody can just tell us, what are things that multiply to 20? 2 times 10? What else? 4 times 5. All right. Now, we have our perfect squares. Okay? 2 and 10 are not on here. Okay? So 2 and 10 are not part of the perfect squares, but 4 is. We know what the square root of 4 is. What is it? Good. We need to, this week, start talking like that. Okay? We got to think like that. Okay? So this one becomes, we're going to bust it apart. The -7, we're happy. The square root of 4, we know what to do with. The square root of 5, we don't know what to do with. Okay? So, we're going to simplify by factoring out the square root of 4. Okay? So, we have -7 times 2 times radical 5. Well, we know what -7 times 2 is. Okay? And if you need to, pause the video, grab your calculator, test it. -14 radical 5 is the same as -7 radical 20. Okay? Now this video went for 20 minutes. I'm going to pause and then we'll come back for part 2 and we'll do the rest of, we'll go as far as we can today with this cheat sheet. All right? Talk to you soon.